The last exponent rule that we're going to talk about is called the power rule. And this deals with raising a power to a power. So for example, if I have a to the m all raised to the n, I take those exponents and I multiply them together. Now there are some extensions to this rule. We've got raising a product to a power and raising a quotient to a power. So let's just say we have a bunch of stuff in parentheses that's all multiplied together, because that's what product means, and it's all raised to the n power. What that means is everything inside the parentheses gets raised to that power. It's a little bit like distributing, but it's not exactly the same. Now for a quotient, anytime we've got a fraction raised to a power, everything in the numerator gets raised to the power and the denominator. So here's where you need to be careful with this rule. It's a very handy rule to have, but it does not work for addition. So I see this all the time. We just sort of get in the habit of using the rule. So if it's addition or subtraction, so let's say I have x plus y to the third. That is not x to the third plus y to the third. Okay, so this is something that you need to be really careful of. It does have to be a product or a quotient. If we have any pluses or minuses in there, we would have to write this out 3 times and multiply it out. But we don't, there's not like a quick, easy way to do that. All right, so let's look at some of our examples. Our first one, we have y to the 6th squared. So if I use my rule, I know that I should multiply the exponents and get 12. Now if we think about why the rule works, remember the exponent tells me how many times to multiply the base. Well, in this case, the base is y to the 6th. So what it's telling me to do is take y to the 6th and multiply it to itself 2 times. Then I could use my product rule and I could add those exponents, and that would also give me y to the 12th. So when I see these, I tend to think of these as 2 groups of 6. So for this one, I would think 2 groups of 5, which would give me 10. And this is how I keep it straight when I add and when I multiply. So 2 groups of 3 would be 6. So 2 to the 6, I can actually multiply that one out. 1, 2, 3, 4, 5, 6. So that would be 4 times 2 is 8, times 2 is 16, then 32, and then double that to 64. All right, number 4 is using this product to a power. So notice all of these are multiplied and they're all raised to the 3rd power. So that means the negative 3 gets raised to the 3rd power. The x to the 4th gets raised to the 3rd power, and the y squared gets raised to the 3rd power. If people miss one, they usually miss the coefficient. This will be negative 3 times negative 3 times negative 3, which is negative 27. And we have x to the 12th and y to the 6th. All right, same thing on number 5. Everything in here is being squared. So the negative 6 gets squared, the x gets squared, and the y to the 3rd gets squared. So negative 6 times negative 6 is 36. This is just x squared, and then y to the 6th. Okay, so notice that negative went away when we squared. All right, I have 1 over x to the 4th, so this is going to use my quotient rule. So the 1 gets raised to the 4th power, and the x gets raised to the 4th power. 1 multiplied to itself 4 times is still 1, so I get 1 over x to the 4th. Okay, so for number 7, same idea. The 3 is going to get cubed, and the y squared is going to get cubed. So 3 times 3 times 3 is 27, and on the bottom, y to the 6th. All right, so the last problem is a little bit uglier. I'm going to try to give myself some space for this one. So I've got a whole bunch of stuff in parentheses. Notice there's no plus or minuses, so I can use my power rule, and I'm going to square everything. So I'm going to come down and do this right here. So the 3 gets squared, the x to the 4th gets squared, and the y to the 7th gets squared. On the bottom, the 4 gets squared, the x gets squared, and the y to the 8th gets squared. All right, so if we clean that up, that'll be 9 x to the 8th, y to the 14th, over 16 x squared, y to the 16th. All right, so now I need to clean this up. I can't have x's in 2 places and y's in 2 places, so I need to see if I can clean those up. So if I start with my x's, I know if I subtract those exponents, 8 minus 2 is going to give me 6. Since it's positive, I'm going to put those on the top. So the 9 stays here, the 16 stays here, and I'm going to have x to the 6. So that takes care of those. Now there's a couple of different ways to look at the y's. If I do 14 minus 16, I would get y to the negative 2 in the top. So that's one way to do it. But then I have to take that and I have to move it to the bottom. So a second way to think about it is from right here. If I have 14 y's in the top and 16 in the bottom, when I cancel, I'm going to have 2 left in the bottom. So if you think about it that way, it does skip that negative exponent step, and those y's end up in the bottom. But you do get the same thing if you go from here. Remember, anything with a negative exponent, you have to move it down to the bottom. All right, so this would be my final answer. 9 over 16 is reduced. I only see x's and y's in one place, and I don't have any negative exponents.